Understanding wind loads, the silent enemy of tall structures. Welcome to Blueprint to Reality. Today, we're diving into the world of wind loads, an essential yet often overlooked factor in tall building design. Wind loads are a critical element that structural engineers must carefully consider when designing skyscrapers and high-rise buildings. While we often think of gravity as the primary force acting on structures, wind poses a unique set of challenges that can significantly affect the stability and safety of tall buildings. What are wind loads? Wind loads refer to the forces exerted on a structure by the movement of air. These forces come from the dynamic pressure exerted by wind as it strikes a building. Wind direction, speed, and the height of the building all influence the magnitude of wind loads. The higher the structure, the stronger the impact of wind becomes. Wind load analysis is an essential part of the structural design process, ensuring that buildings can withstand not only daily gusts but also extreme weather conditions like storms and hurricanes. The impact of wind on buildings. When wind blows against a building, it creates pressure on the windward face and suction on the leeward side. This differential pressure leads to horizontal forces that can cause lateral movement or sway. In tall buildings, this movement is often felt by occupants, which can cause discomfort. The structure's design must account for these forces to prevent issues like excessive swaying, which can lead to fatigue in materials and reduce safety. Engineers rely on wind tunnel tests or computer simulations to analyze how different building shapes will react to varying wind speeds and directions. Wind-induced vibrations and resonance. One of the most critical concerns when dealing with wind loads is resonance. Resonance occurs when the natural frequency of the building matches the frequency of wind gusts. This can cause the building to oscillate with increasing amplitude, leading to structural fatigue, discomfort for occupants, or even catastrophic failure in extreme cases. To combat this, many skyscrapers are designed with damping systems, such as tuned mass dampers, which are large counterweights that counteract the wind's force and prevent excessive sway. Design strategies for wind resistance. To resist the forces of wind, structural engineers implement several design strategies. They incorporate structural elements like shear walls, braced frames, and moment-resisting frames to enhance the building's rigidity and ability to withstand lateral forces. The shape of the building is also a key factor in wind resistance. Aerodynamic designs with rounded or tapered edges reduce wind resistance, whereas sharp corners or flat surfaces tend to generate more turbulence, leading to higher wind pressures. These considerations are factored into the design from the early stages of construction. Wind codes and standards. Wind load design is governed by a set of standards and building codes that help ensure buildings are adequately protected against high winds. In the U.S., ESC 7 provides guidelines for calculating wind loads based on factors like building height, location, and exposure to prevailing winds. Similarly, in Europe, Eurocode 1 outlines wind load calculations. These codes are essential for engineers to ensure that buildings meet safety standards and are resilient in the face of extreme weather events like hurricanes or tornadoes. The role of technology in wind load analysis. Advances in technology have significantly improved the way engineers analyze wind loads. Modern wind tunnel testing and computational fluid dynamics (CFD) simulations allow for detailed studies of how wind will interact with the building surface. This data is used to refine building designs and make them more efficient in resisting wind pressures. In addition to this, the use of AI and parametric design has allowed for more innovative solutions, such as smart buildings that can adjust their structural response to wind in real time. The future of wind load engineering. As urban environments continue to grow and skyscrapers reach greater heights, the science of wind load engineering will become even more critical. We can expect to see even taller structures that are not only resistant to wind, but are also designed to harness wind energy for sustainability. The integration of green technologies and adaptive design will ensure that the buildings of tomorrow are both resilient to the forces of nature and energy efficient. Structural engineers will continue to innovate, creating safer and more efficient buildings that can withstand the challenges posed by wind loads. Thank you for joining us in exploring the fascinating world of wind loads and their impact on tall structures. If you found this video insightful, don't forget to like, share, and subscribe to Blueprint to Reality for more civil engineering content. See you in the next video.